Okay, so hey everyone. So we have Matt. So we have with us Matt Coulter today. He's working as a senior architect for the company Liberty IT. Matt is focused on creating the right environment for empowered teams to to rapidly deliver business value in a well-architected, sustainable, and serverless first way. Matt is the creator of CDK patterns, an open source collection of well-architected serverless patterns in AWS CDK. He's also the founder of CDK Day, a global virtual conference to celebrate the CDK community, and he's also the co-author of CDK book. So let's hear from him. Over to you, Matt.
Awesome. Yeah, thank you for inviting me and thank you for the intro. So yeah, so today everybody, what I'm going to talk to you about is well-architected serverless first development with AWS CDK. And yeah, you've already had me intro, so I'll not spend any much longer than that. I'll jump over to the flow of how we're going to go through this is we're going to start and explain what actually is serverless in 2022 because it's been around a long time as a term, and I always think it's worth level setting. And then we'll dive into the difference between serverless and serverless first because they're not the same. Then I'll talk about the AWS Well Architected Framework and how you can use it to run well architected reviews. We'll then move into AWS CDK versus SAM versus Terraform versus CDK for Terraform. And we'll talk about how all these things aren't as different as we necessarily think they are from the onset. Then we'll bring it all together and start talking about combining AWS CDK patterns with the well-architected review process. And then we'll go into well-architected constructs. And then because I ran out of vertical space, just you'll have to wait and see what further resources means. So first of all, the most important thing, what is serverless today? And this is the thing where the term has been around since, I don't know when, officially what year it was. It was like 2011 or something that serverless became a term. And if you think about it, the capabilities that have been launched in that space of time between then and today, it's night and day. So it's one of these things where there's a lot of articles and podcasts and YouTube videos out there with opinions on serverless, but they were written at that point in time. And that's why I just want to level set because a couple of years ago, if I had posed this question, does serverless mean AWS Lambda? I'm pretty sure that if it was a room of 100 people, about 100 people would have raised their hand and said, yep, serverless is Lambda. But today, the answer that I would like people to give is not just a straight up yes to that. The answer is that serverless is not just Lambda. And in fact, Lambda isn't even the ultimate destination for serverless architecture anymore. Lambda is just the most famous piece. And that's why you need to understand the whole ecosystem of what serverless is before you can talk about the strengths and weaknesses. Because I always feel a lot of the pros and cons always get tied up with Lambda and ignore everything else that's out there that you can use. So to talk about what's on the official list of serverless components, this is what's on the aws.amazon.com/serverless site. Now, I know there's a lot of other services that AWS officially advertise as serverless in some way, but rather than getting into that debate, this is what's on the serverless page, so this is what I'm sticking to for today. And you can see Lambda is there on the left as compute, and the idea behind it is I have a piece of code that I just want to run. I need it to run and then finish and give me the output. That's what Lambda is. And it scales based on if a second person comes along and wants to run the same thing, I'll just spin up another one. I don't need two people hitting the same instance of a Lambda function. And then if you have the same idea, but instead you think, no, I need a container that's long running with concurrency, well, that's where AWS Fargate comes in because that is similar to Lambda in that it is serverless, but it's a managed container offering that can spin up with multiple concurrent users. There is a blurred option between the two today in that you can use Lambda container images, which allows you to use containers with Lambda, but it doesn't change the execution model. So it's still one request, one instance of a Lambda function. It doesn't allow you to do concurrency. So the real use case behind that is if you need to bundle something that's your own runtime, or you just already have all the tools in place to build a container image, but it does not change the difference between Lambda and Fargate. Then when you start looking at application integration, you've got tools like SQS, which is for queues, then SNS, which is notifications or one-off events to broadcast to multiple users. Then you've EventBridge, which is amazing. It's this centralized bus that you can just fire off events, but then you can write really custom rules on the payload of the events themselves to say who's going to get those events. And it has all the expected enterprise features these days, but with amazing developer focus and simplicity. Then you've step functions, which is another offering that a lot of people don't seem to have played with yet, even though it is incredible. Step functions allows you to build complicated logic in your app. All your 5 million lines of Java that you probably have today, you can define it in a step function, and that's all done through infrastructure as code. And then that way it comes baked in with all your durability, your logging, all of your, you can open up and replay events, see how it's all flowing through your system. So it actually takes an awful lot of the heavy lifting away from running your complicated flows. Then AppSync is the GraphQL way of accessing any of the previous offerings. And API Gateway is the REST way of accessing any of the previous offerings. An API Gateway comes in HTTP API and REST API. Now, not to make it confusing, but the difference between the two is that HTTP API is cheaper, but it has less features. And REST API is more expensive, has more features, and is slightly more complicated. So you probably start with HTTP, and then as you find you need something, move to REST. And then just a couple of weeks ago, speaking of ways of accessing these things, Lambda launched Lambda function URLs, which is a way of standing up a Lambda function and then not needing an API gateway or an AppSync instance to actually hit it from the web. You can just funnel traffic straight through to the function. And this is for your use case of maybe you've got a web framework that you want to put inside the Lambda function, something like Express.js or Ruby on Rails or something of that description. Doesn't need an API gateway because it can handle it. Then the most famous service of all, actually in all of Amazon, is Amazon S3 for storage. It's completely serverless because all you do is say, I want to store this thing, and you don't worry about how. Then for databases, DynamoDB is another big one, your NoSQL wide column database. And then RDS proxy is a really cool one. It's a connector between something serverless like Lambda and something not serverless like RDS. And it allows you to not have to worry about Lambda scaling up and making your RDS instance fall over, because it'll handle all of the caching and all of making sure that one can scale far quicker than the other, so it works it out. But it also means you don't have to pass the secrets into the Lambda function itself. It can use native IAM authentication between the proxy and the Lambda function, so it makes things a lot more secure. And then the last one is Aurora Serverless, which is your more traditional Postgres kind of database, but in a serverless-ish manner where it doesn't quite scale to zero, but it does scale up and down, and it's the V2 just launched GA there last week. So the point is, it's a lot of things. Serverless is not just Lambda. Lambda is just the thing on the far left that it really captured the world's attention a few years ago with this idea of just put all your code there and not need to worry about hosting. But it's way more today. So this is how Amazon defines it. They talk about serverless as about rapid speed to production. Anything serverless, you should be able to go from nothing to being able to have it stood up in production really, really rapidly. You shouldn't have to go in and customize a thing. You shouldn't have to go in and start with a thing, spend 20 minutes, deploy another thing, jump back. It should all just work, and it should be fast. And with that speed, it should also be massively scalable. So it's not a case of you build something in your non-production region and then you hit production and realize that it's not going to scale to 400 users. It's not infinitely scalable. We've definitely proved in Liberty there are limits, which is good, but it's the level of scale that by the time you're hitting all those limits, it's worth a conversation with AWS anyway. You should be big enough for that. Then it's got this brilliant model of pay for what you use. So it's the a la carte option of infrastructure on AWS. And the idea is you pay for it. Lambda's the easy example. pay for every invocation. Or EventBridge, I think it's you pay for every message received as opposed to it's either sent or received, but the point is everything is paid for what you use. So it means that if you are a startup, or even if you're someone who has an unpredictable level of users, well, then you're paying for exactly where your users are and when they use the system. So if something like COVID hits and you're a business that relied on people to be in a large venue, well, all your infrastructure costs just went down because you were serverless. Whereas if you weren't serverless, you would have had to decide what to do with all the servers you provisioned. And then the last thing, serverless isn't about writing tons of code. It's about how can you solve a business problem with the least amount of code possible by stitching together all of those components that I mentioned before and only focusing on your business logic. That's what serverless is, and I'll jump into that slightly later. The one thing I just really want to point out, because I always like to tell people this, serverless, the technology, AWS Lambda as a technology is always serverless because it is. It's a serverless technology built in a serverless way, but your use of AWS Lambda is not necessarily serverless, and that is completely okay. It's just something you need to understand and own when you're building architectures, because I think a lot of the time, Lambda is so flexible now, especially with the container image support. You could, for sake of argument, spin up a Kubernetes cluster inside a Lambda function. And you're not going to get your concurrent users or anything to take advantage of it. But the point is, it's just not really a serverless implementation at that point. In the same way as if you buy an electric car and you buy it for the purpose of being greener and saving the environment, it's electric, it's greener. But then if you spin up a diesel generator and plug it in to charge it, all of a sudden you've defeated all the purpose of doing it in the first place, and people will start asking questions. Still an electric car, but you know what I mean? So that's why I'm saying just be honest about what you're building. It's not a big deal. And why should you trust my opinion or Liberty Mutual's opinion on this stuff? Well, if you go to aws.amazon.com/serverless, rather than me just give you a 20-second blurb, there's actually a full story written there about some of the things that have really worked out for us with serverless. And it's right on the customer section of the Amazon page. It's all the things like when COVID hit, I don't know if it happened there, but in America anyway, and I think in the UK, because everybody was in lockdown, all car insurers gave money back to the customers because no one could drive their cars. So all those kind of things spin up your refunds infrastructure, but at the same time, there's no claims. So your claims infrastructure usage goes down. So this is a really good article on the examples of how Liberty Mutual has been helped by serverless. So that was serverless. But what's the difference between serverless and serverless-first? Because it's 2/3 of the same thing based on the name. Well, the serverless-first is all about this mindset. It's the mindset that code is a liability. It's not an asset. The outcome that the code generates or produces is the asset, but the actual code itself is always a liability, because the less code that you can maintain, the more time you can spend focusing on business value, talking to customers, and winning whatever market you're playing in. Because if you really, really think about it, you could have a business that are brilliant at what they do. They could be incredible. The customers could be delighted, but they may have, for sake of argument, 3 million lines of custom code. And that could be what they see as their advantage. They're not even using the likes of Spring Boot. They've written their own framework and they're deploying everything on-prem themselves and everything custom. But then something happens like the other month whenever Log4j has a vulnerability. And that company has to go through every single line of code that it's running and look inwards to make sure that they're not exposing a customer to any kind of risk before they can look outwards for new features. When those kind of things happen, you just have to stop, assess, and say, are we good? Yes or no? And if the answer is no, all resources have to go into fixing that problem. Whereas if you have a second company that's achieving the same outcome, but has way less lines of code, for the sake of argument, say they have 50 lines of code and they're able to do it because they're just stitching together all these cloud services, Well, when something like Log4j happens, they know that the cloud provider has to fix that quickly. So you can open a support request and say, I want you to tell me that Log4j is mitigated for in all the services I use. And while they're doing that, you can go out and still speak to your customers, focus on new business features, and actually take market share off the company that was winning because they're too busy focusing on all their liability. So as I say, it's about how can you achieve the outcome with the least code possible. And you might say that, well, that's the exact same as serverless. Why, that's not different. But the difference here is that, yes, serverless technology shifts undifferentiated heavy lifting to the cloud provider. But unless your business is brand spanking new, like right now, you will have some code that you have already written. That's just a matter of fact. And if you're in a business that has been successful for decades, you will have some really old code that is providing value to your business. So you can't come in and say, we are serverless now. All of that is crap. That's out the window. Forget about all that success. We're going to rewrite everything. That is not a smart business strategy. The business strategy is something different, and I'll talk about that next. But I just want to say, serverless first does not mean and never will mean serverless only. It's about going through all of the code that you already have, the services, everything that you've already built, and understanding how much value it provides the business versus how much liability it has. An example of this could be you might have still code running on the mainframe. And the fact that it's still running on the mainframe in 2022, that tells you it's so core to your business. It's probably bringing in millions per year, but it's also probably costing millions per year because of the fact that you have to keep a mainframe, and the mainframe is probably on-prem in a data center that you've got to pay for the lighting, the heating, the person to clean the data center. Like, there's a lot of costs involved in those kind of things. So you decide you want the outcome that code provides, but you don't necessarily want all the liability. And you need a process to decide how can we migrate those things and where's the right place to put them. And that's a process that we like to call falling back to the right option. So the idea is you start with the most serverless implementation, which is actually to do nothing. And then you keep falling back to owning more liability until you've hit that Goldilocks solution that's the right one for your needs. So this diagram is really old. There's a bunch of services missing. So there is, if you look at it and you're going, yeah, wait, where's EventBridge, for instance? This was shared in reInvent at 2018, and the talk is at the bottom. You can go and watch it if you want. But the idea is serverless is a spectrum. You can see on the left, we have more operations, and when it goes from purple to pink, it goes the right way to less operations. And we've got Lambda in the bottom right, which sort of goes to Fargate, ECS, Elastic Beanstalk, EC2, and then on-prem at the outer edge. So the idea of taking advantage of the spectrum is that we fall back to the right option, like I mentioned earlier. Take that piece of code that was running on the mainframe. I mean, in an ideal world, you would be able to look at it and say, oh, this is really easy. This could be rewritten using direct integrations like API Gateway, directly integrated into a step function, directly integrated into DynamoDB, and have only infrastructure code, no other code, which means you'd have shifted all your liability to the cloud provider. But if it was that easy, it wouldn't still be on the mainframe. So you fall back and you say, okay, can I run this piece of code in AWS Lambda? Maybe you package it as a container image and you bundle your runtime inside that container. But maybe for this particular instance, the execution model of Lambda doesn't work for this piece of code. Maybe the fact it doesn't do concurrency means that it would be too expensive to run it there. So you fall back and you say, I need a long-running container that can take concurrent requests. So you shift it from Lambda to Fargate. Not a lot of changes. But maybe, for the sake of argument, the Fargate runtime, maybe it's too slow. Maybe you need something more powerful. So you decide to fall back again to Amazon EC2 because you can you can make a pretty beefy EC2 instance. But that still doesn't work because you realize that it's talking to something else that's on-prem. So it's actually been latency the whole time that's been what has been slowing it down. So you fall back to keeping it on-prem. And you might say this was a point in the cycle, Matt. Why did you go through this whole thing? You've ended up on-prem anyway, which is where you were. Because now you're in a beautiful situation where you know exactly what it would take to move it up this hierarchy. You know that it's talking to probably a database was the thing it was talking to that's on-prem. So you can now make a plan to shift that database from on-prem to, for the sake of argument, Aurora serverless, rather than doing a big rewrite. And then once you've got it on AWS, you know you can probably shift this straight up to Fargate really easily, reduce your costs, reduce your liability, and you'll know exactly what it would take to move it higher at a later date. So that's the beauty. It's scientific. It's backed by data, as opposed to just gut feel and going, yeah, it's running pretty well. I don't think we could move it. The other thing about serverless-first architectures, they are serviceful. And I've no idea if that's even a word, but I think you get the meaning of the feeling behind it, in that if you have these architectures like the one shown, which is not a real architecture, I've just made it up for the purpose of this diagram, but you can have an architecture that has an API gateway that's protected by the Amazon Web Application Firewall, the WAF. And that API gateway can use something like Auth0 or Ping or Cognito for security. The API gateway can be directly integrated into the step function service. And that step function can hook into external services like Google or a Liberty Mutual API or something else like Datadog to send in metrics. But the point of this slide is literally everything outside that yellow box is a managed service. It's something that somebody else is looking after, the associated liability of keeping it up to date. They're making sure that you have some kind of contract with them that says, I expect this level of uptime. I expect when I make a call, this is what happens. So you can focus on the yellow box because that's your business. Whatever that logic is inside that yellow box, whatever that step function is doing, that is what is making you a success in your market. And you can take advantage of step functions to implement it. But the point is, whatever way that's configured is what you should care about in this diagram. And you can spend all your time refining that step function instead of worrying about everything else. And that's where you should end up. So this is one that I always like to throw in here, because you might say, well, that's brilliant. You've said that we need to understand how much value is provided by all of our code. But you haven't actually told us how. You've just assumed that we're going to know the value and the liability for everything that we have, which most people realistically don't. So this is a technique that I like to use. It works for me. It may work for you. But this is called Wardley mapping. And that's Simon Wardley on the right, his Twitter handle, and a link to his Medium that has all the tutorials for how to do a Wardley map. But I'll explain this one really quickly for you. We have a map which is on two axes. So the vertical axis goes from invisible down here to visible up here, and it says value chain. And then this other axis is Genesis, custom build, product, and commodity on the evolution. So what this means is, on this vertical axis, anything that's up here at the top is right in front of your customer. They see it, they care about it. If you change it, they will ask questions. The further down it goes, the more they will not care if you swap it out, because it's just something that behind the scenes is involved in the process of what they're doing. But realistically, if it's down in the invisible section, you can change it as much as you want, and providing the outcome doesn't change to the user, they won't care. The horizontal axis is broken down into these categories, which means Genesis is nobody else on the entire planet has done this before. We think that there is massive competitive advantage in us investing money in this. So you shouldn't have very much in Genesis. People always seem to try and aim for Genesis, but you need to understand the implication of putting something in there. It's the first, it's really experimental. Then custom built is saying that there are other things out there that might meet your needs, but you've decided that none of those work, so you're going to build something to solve it yourself. Product, you bought something off the shelf. There's offerings out there and you said, yep, one of those works, so I'm going to use that product. And then commodity, the idea behind commodity is it's like electricity. Outside of caring about the sustainability of your electricity provider, it doesn't change the electricity that comes out of your plug. You can swap electricity providers all day long, and the actual electric that comes out of the plug is always the same. So that's a commodity. And on this diagram, you can see this is a coffee shop or a cafe, and this, it should say customer, but this is a user buying a cup of tea for 55 cents, and 5 cents is going back into the business from this. So there's 5 cents of profit, you may call it, from selling this cup of tea. And you can see the cup of tea is a product because tea leaves are pretty easy to acquire, and there's nothing unique about this cup. And it's made up of a cup, super easy to acquire, commodity, cup's a cup. Tea, again, there's no special tea in this instance, it's just whatever tea they could acquire. And then staff, they're not a commodity, but they're a product in this instance because you might be going to an agency and getting them to serve this. It's not a highly specialized role. Then the cup of tea is also made up of hot water, and 20 cents out of every 55 cents is going into this water. And 5 cents of that is going into the water, and 15 cents is going into this kettle that's in the custom built section. And then of that 15 cents, 5 cents is going into the power, which is the commodity. The thing that should really stick out here is that this is a custom built kettle. This is some kind of proprietary kettle technology that this company, for being a cafe, has decided to build. And it's costing them 10 cents on every transaction. Whereas if they just bought a kettle off the shelf, it would probably be a product somewhere over here, and they might save 8 cents more on every transaction. So they could turn profitability from 5 cents to 13. And you can do this process for every architecture you have out there. You just start with the user and keep drawing all the nodes on the map until you've completed the whole user journey. And you should be able to see this kettle in this instance could be something that John maintains under his desk that's vital to all the infrastructure, but nobody cares about it because it's invisible. That's the point. Okay, so that's serverless first. But now let's talk about the AWS Well Architected Framework, because this is fundamental to how we build serverless first solutions on the cloud. Because there's a lot of components out there, but if you're going to stitch these all together, you really need to understand how you're going to do it. And this is built on 6 pillars. The 6th was actually only launched at reInvent in December there. But I'll briefly go through what all the 6 pillars are. Operational excellence. These are the official definitions, but I'll give you the Matt Coulter short version. Operational excellence is how do you know what your system is actually doing? Because you know it's running, you know it's taking requests, but do you know it's doing what you think it's doing? Security is everything. I mean, this one's obvious. Is the access to your system secure, but also all of the data and all of the assets, are they all secure as well? Reliability is looking at if your system's going to fall over with a light breeze, or if one region on AWS was down, is that okay for your business? Or is this mission critical? So you should have some kind of multi-region architecture to account for the fact that sometimes regions go down. Performance efficiency isn't actually about saying how fast can we make it. It's about saying for your users' expectations, is this meeting them? Should it be faster? Should it be slower? What is the performance like? Cost optimization without impacting your performance. Can you save money by changing some configuration? And then sustainability is about looking at your impact on the planet as a whole. Brand new, but the idea is if your app is a monolith that takes 45 minutes to build and you have 10 concurrent builds running 8 hours a day because you have so many developers working on it, think of how much carbon you've pumped out into the planet by that running on some kind of big beefy build server constantly all day. And it's even down to that amount of code, you're having to save it in your artifact store, every version of it. and that's just building up and building up and building up. So you got to think about all these things now, and it's an evolving space, but really interesting. So the well-architected framework is like the guide for the cloud written by the smartest minds at AWS about how they build things. It's huge, but they've also broken it down into more specific white papers that they call lenses. And these lenses they're either for an industry or they solve a particular problem. And luckily enough, there is a serverless lens of the well-architected framework. And the serverless lens covers all of the serverless use cases of all of those pillars. And then the well-architected framework and the lenses are operationalized through a thing called a well-architected review. The well-architected review it's a process that can take advantage of lenses, or you can do the full well-architected process that I'll go into more details in a second. But just to say, we love well-architected reviews at Liberty Mutual. This is something that we talk about pretty much every day. And I do not remember giving this quote, but I'll stick to it. If you go to the well-architected page, you can see that Liberty Mutual's there as a customer. So we know a thing or two about it. And let me just tell you now how we do it. So the well-architected reviews are done in the AWS console. There's a section there called the well-architected tool, like I mentioned. And in there, you just go define workload. And once you start defining a workload, it'll ask you some questions like which account is it in, and do you want to give it a name? Some basic questions. And then from there, you can pick whether or not you want to do the full-blown well-architected review, or do you want to narrow it down to a specific lens. And that's where the image on the right is the serverless lens. And you can see it's not very long. It's broken down by this was taken before the new pillar. So, but these are what was the 5 pillars. And inside operational excellence, you can see it just asks 2 questions, like how do you evaluate your serverless application's health? And then from there, it gives you the option to say it doesn't apply to us, as well as a bunch of checkboxes, multiple choice that you can tick. And it also has a notes section. So this isn't a tool that you can go in and use, unfortunately, with no knowledge of AWS, because you can just tick all the boxes and say you're doing it, and it wouldn't help you in any way. But the way we use it is you would sit down with somebody like me, and we would go through this process and ask the questions. And as we go, I would say, okay, how do you understand your cloud workloads? Do you have any CloudWatch dashboards, for instance? And they may say yes or no, but we'll write all the notes as we go. And by the time we get to the end, the amount of knowledge sharing that has taken place is incredible, because we've taken this structured format for how we're going to have the discussion. And it doesn't end there. It produces a well-architected report and an improvement plan and milestones. So you can go in, based on what you answer, it can say, we think in this case you have 8 high risks and 1 medium risk. And what you can do with that, you can either go through this and say, do you know what, we don't think that's a risk, we're not going to mitigate it. Or you can put it on your backlog and prioritize it with your product owner like any other feature. But instead of an architect having to try and explain why this is important, you can back it up by all of the AWS documentation and white papers and links and papers, send them this talk. And that's the idea. You can track this over time. And that's why there's milestones, because there may have been 8 high risks and 1 medium risk today, but we'll do another review in 3 months and we'll be able to compare whether it went up or down and have that conversation then. Okay, so yes, that is serverless first, well-architected and well-architected reviews. You're now ready to deploy something to AWS because you're ready to write the least amount of code possible to solve a business problem. But how are you going to do it? Well, that's where we use AWS CDK. CDK is the cloud development kit. And this is the official blurb. Use the AWS CDK to define your cloud resources in a familiar programming language. It's available today in JavaScript, TypeScript, Python, Java, C#, and Go. And that's pretty much, it does say what it is. Instead of using YAML, which is what a lot of other tools use, CDK is empirical code written in a declarative way. I'll show you what I mean by that now. On the left-hand side of the screen, we have AWS CDK, and this is TypeScript. And this is, standard TypeScript. You can see we've got comments in here. So we've got comments to say what it is, and then we can name things. So this is a DynamoDB table that's pay per request, and it has just one column in this called path, which is a string. We also have a Dynamo Lambda, which is a Lambda function, which is Node.js 12, so deprecated, should update this. It is pulling in a handler of lambda.handler, and it's passing in an environment variable of its table name of table.table_name. And you can see I didn't have to hard code that table name. I can just refer to this DynamoDB table and access that table name property, which is amazing. Then we can do really cool things like this, because there's some helper functions written into the classes, or constructs as they're called in CDK, that you can say on this table, grant read-write data access to this Lambda function. And that'll write the IAM permissions for you in a least privileged way. And then you can just go, okay, I want a new API gateway, HTTP API, with a default integration of a Lambda proxy integration that's the Lambda function I just created. So we've just created an architecture that's an API gateway with a Lambda function with permissions to integrate with a DynamoDB table that we created. That's quite complicated to do. And the one thing I want to say is the image on the right is the CloudFormation for this, which was generated through CDK synth into that file. But it's not a versus. This isn't a competition. The point is these two things are the same. The CDK at deploy time becomes CloudFormation. So you can use all of your CloudFormation tools to validate CDK. It's just a way of, if this resonates with you, if you're an engineer from a traditional background who doesn't really enjoy writing YAML, well, guess what? You can now write TypeScript in this way, and you'll get your IntelliSense, you'll get comments, you'll get pull requests, you'll get all those things, but still wrapped up in the safety of CloudFormation. And it even allows you to write unit tests. Because it's code, all of a sudden, all of our standard practices just start coming into effect. And this unit test, you'll either decide if it's useful or not, but you can go, let's check that this template has a Lambda function. And template is CloudFormation template, remember, in this case. And let's check that, first of all, the handler is lambda.handler and the runtime is Node.js 12. You could be like, Matt, that's a pointless test. Why are you showing this? Write a better test for your presentation. Because the point about unit tests, and it's whenever I talk to people and they say to me, I don't need unit tests, I know exactly what my infrastructure code is doing when I deploy it. Well, the two things are, first of all, unit tests are not necessarily for you. And second of all, if they are for you, they're for you at a later date whenever you've forgotten why you set that configuration like that. If we could always remember why we wrote our code the way we did, unit tests would never have written. These are a way of having that team knowledge that requires a conversation embedded into the pipeline so that you stop people doing things they shouldn't. And in this particular instance, this Lambda function may only work in Node.js 12, which has been deprecated. And if somebody comes along and just updates it, you can never roll it back because it's deprecated. You can't deploy those anymore. So all of a sudden, it might be a big story to refactor this Lambda function, which was in the backlog anyway. And this unit test could stop someone deploying that change because the message could say this function cannot be updated until this story is completed. That's what you can do with unit tests, and that's why I'm excited about it. If you're one person working on a small project by yourself, I'd still write the unit tests, but I get why you wouldn't. It's when you become a team and you've something that you're keeping running, it's really cool. And the whole point of CDK, it loves reusable patterns, and it can be done in a couple of ways because CDK is built on this technology called JSII, and that allows you to write a construct, a piece of code in TypeScript, and go through a process that allows you to publish that same piece of code to be used in all of the CDK languages. So you can write TypeScript and have Python users, .NET users, Go users, all of a sudden they're using your classes at that point, which is awesome. And that SPA deploy one, that construct's just an example, written in TypeScript, and there's the Python implementation. It automatically renames things into their local, like the way Python's underscore and JavaScript's camel case. It's all those kind of things. And you can also pull together multiple constructs into one place to solve a business problem. And that's what we call a pattern. And that's what CDK patterns is. It's a bunch of open source constructs that were inspired by the AWS heroes and the people in the community that are solving problems, but they're done in a way that you can just pull them down and deploy them in a couple of commands. So, as you might have guessed, we use CDK incredibly heavily in Liberty Mutual, to the point that Werner Vogels, as CTO of Amazon, included my quote in a keynote in AWS America's Summit last year. And also I got an 8-minute slot in his keynote in reInvent in December there. So the links are at the bottom. They made a case study out of the reInvent talk. And if you want to hear some of the benefits we've got out of it, it's definitely worth going and checking those out. But the only real thing to point out is that we don't mandate which tool developers have to use. We always go with the attitude that you use whatever tool makes you most efficient, whatever makes your team happy and gets business value out the door. And there was a survey done between developers, and I think it was 78% of developers said they preferred AWS CDK. So it hasn't been mandated, it's just taken off through popularity. I've never seen that before. So there are other options out there for infrastructure as code. And that's where the big comparison is, should you be using SAM, the serverless application model, for serverless architectures? Why are you using CDK? And the thing is, it's not a versus. We always fall into this versus situation, but it's actually an and situation. AWS have gotten pretty good that now all of the CLI features of SAM are compatible with CDK. And what I mean by that is SAM has a bunch of local features, like Software Accelerator is about rapidly pushing changes to the cloud as you're making them in your IDE. And the other ones are SAM Local is about API Gateway and Lambda. It'll stand them up locally so that you can test your API before you deploy it. All of those things work with a CDK stack. You can run a couple of commands and you're using the SAM CLI from a CDK project. So you can combine them both based on your team's personal preference of whether you want to write TypeScript, Python, or whether you're a YAML team. That's the point, it's down to preference. And the link's there on the screen if you want to know more about those two being integrated. But there's a phenomenal talk Eric Johnson gave at CDK Day last year, which is where they launched it, and he demos it. Then the other thing is, okay, so you've talked a lot about CloudFormation, Matt, but we use Terraform. And if you don't use Terraform, the difference between it and CloudFormation, it's really all down to state management. CloudFormation is a managed service. So when you start deploying infrastructure code, you can close your laptop and it'll continue to deploy until it's finished because AWS are handling that deploy for you in the cloud. Whereas Terraform, it's all about local state management. So your deploy all happens from your computer. And instead of going through a managed service like CloudFormation, it'll hit all of the APIs directly to spin up the resources. Now, there is a CloudFormation adapter that you can use with Terraform. I'm just speaking generally here. But the point is, if you're using Terraform, you can integrate it into more things. Because it's not CloudFormation, you can integrate into anything that has an API. And that's why people typically use it. Well, the thing is, first of all, that there is a project out there called CDK for Terraform, because CDK has always been about that JSII technology and this idea of allowing you to use your empirical language in a declarative way. So Terraform is just a different output to CloudFormation template, and that's why this project exists. But what's even more beautiful about this? You can now use CDK for Terraform and AWS CDK together. So it's not locked in. This is still in preview, but the vision for this is that you could build a serverless app in CDK, and then all of a sudden you want to integrate with something that's not AWS, and you think, this would have been brilliant if I'd used Terraform, but I've already written my whole CDK stack. Well, with this, you should be able to bring in that CDK stack into a CDK for Terraform project without any changes, and then just start writing your Terraform the way you were writing it before and combine the two things. So it's not about lock-in, It's about what are the best things that you can take away to move quickly with these technologies. So now you know what CDK is and how it's not locked in anymore. How do we combine it with what I talked about earlier, which was well-architected reviews? Well, if you go out to the tool, the well-architected tool in the console, and if you run a well-architected review, you'll get those best practices that I mentioned earlier in your action plan out of the end. And they'll be based on a pillar, and in each pillar there's questions, and in each question there's multiple pieces of best practice. But what I've done is on the CDK pattern site, underneath those best practices, I've tried to associate a CDK pattern. So if you do a well-architected review and you find out under operational excellence that you need to have CloudWatch dashboards, you just come to the site, find this pattern, which just so happens to be for API Gateway, Lambda, and DynamoDB. And it's right there, all the metrics, alerts, and dashboards, deploys in 2 commands, and you've closed a well-architected gap by doing a review and then finding a pattern that solves that problem. Now, I will say, I keep saying, but I will do it, that I need to update these from CDK v1 to v2, which went GA in reInvent there. It shouldn't actually change the patterns too much, because the big change with CDK v2 was about, so when v1 was launched, it was really clever. What they did was, whatever pieces of AWS you were using, it broke them all out into separate packages. So you could say, I'm going to use API Gateway now. And then you had the npm or yarn install the API Gateway package, and it kept everything as small as it needed to be. But they realized it caused 2 problems. The first one was developers could install a capability like Lambda a couple of weeks later, and a new version of CDK could have been launched since then, and it could be incompatible. Maybe so you have to keep all your components on the same version of CDK, and people got really confused by this. So it did. So the other thing it caused was, because everything was separate, it wasn't clear what was experimental and what was stable. So you heard some complaints about, I just updated and my app has broken. And so what they've done now is, with CDK v2, everything that's stable is just bundled into the standard CDK install by default. You don't need to bring it in anymore. And the experimental things, they've left them as an optional install, which means you know that you've had to bring it in. So it's experimental, the API might change, but anything that's in the core, it'll always be whatever version of CDK you're using, because it's bundled together. So that problem's gone, and you know the API is stable forever. That's the commitment. It'll never break. So the reason why I'm saying that is because all of these patterns, if they're using the stable constructs, which they mostly are, the API is locked in. It hasn't changed between v1 and v2. So it's mostly a matter of me going through and just refactoring the actual CDK packaging around them. So yeah, let's talk about well-architected constructs then, going the other way. The first thing I want to say is we use a thing called the Software Accelerator. And this, the reInvent video, if you watch it, explains it in detail. But this is a place that developers can go. And we have all of our CDK patterns in there that I mentioned before, that you can just pick one, and it will set up a code base, build and deploy pipeline in seconds for people to use. It's pretty cool, and this has been how we've created our focus, because anybody can contribute as well as consume. But unfortunately, this isn't an open source thing that you can pick up right now and just use. So that's why I'm going to say that there is an external project called the Construct Hub. That this is a place that houses all of the externally published constructs. So there's over 1,000 now. That happened about a week ago. And you can just go in here. You can filter them by official ones from AWS or partners like MongoDB. But you can also filter it by language or by CDK. And this is all of the ways to solve problems. The interesting thing about the Construct Hub is it's also a construct itself. So you can actually deploy the Construct Hub internally in your company. So if you're building your own constructs and you want a way to share them, the Construct Hub internally and externally is an option. And I don't have a slide for it, but the other option that's not CDK specific, of course, Software Accelerator, is look into something like Spotify Backstage, which is an open source tool that sort of fills a similar need. The other option is AWS have actually written well architected constructs, and these are in the construct hub. So if you use it, you'll find them. But these are like service to service offerings, so that they're like jigsaw pieces that you put them together to solve a problem. Now, the one thing I just want to mention about them is they were written by the AWS Solutions Architecture team, so that the solutions architect's definition of well architected. Don't expect to see them reference the well architected framework, which is my beef with it. And I'm just telling you so that you understand they are well architected, but it's because it's architects in AWS that ran their internal well architected review on them. So hopefully someday they expose the standard well architected as their basis for this, but they are good. So if you're going to create your own constructs to solve a problem in your company with AWS CDK, what are some of the do's and don'ts? As I just mentioned, the first thing to do, always related to the well architected framework, because the amount of times, whether it's CDK or something else, one of the best engineers in the company will always say, I've solved a problem. And everyone else will always look at it and think, you've created bloat. And the only way that you can understand what they've created is to have maybe a 2-hour meeting and they explain it all. Whereas if everything you use or create is using the same common language of the well architected framework, it's really quick for me to jump in and go, okay, that is good, versus no, that's just your opinion. And in the same respect, don't try to abstract the cloud. You might say, well, that's what I just said CDK is good at. CDK is good at abstracting all of the configuration you need to set, but don't ever try and pretend from your users that they don't have to maintain what's deployed. So always bundle in like images of the architecture that's actually being stood up, as well as guides for how people just keep this thing running. Because if I deploy a construct, I am the one that's responsible for the operational excellence of that construct. So just let people know. The other thing is you should try ProGen. It's another project from the CDK team, and it's a CDK for project configuration, but it's really easy to stand up a CDK construct with it because you can just do like ProGen new construct, and it'll set up everything you need to publish to all of the languages. You can do it by hand without it, but all I'm saying is it took me a while to do it manually, whereas ProGen is really quick. Don't forget object-oriented best practices as you're setting this up, because it is code at the end of the day. So think about how you're naming things, think about how you're going to make things easy to test, and think about the size of your stacks. Because I've seen some CDK projects and people, like I've seen bad code everywhere, including YAML, by the way, but I've seen some CDK projects and like people use CDK to abstract everything, and then you've just got a YAML file. And underneath you look at it all, and it's specific classes like Matt's API gateway. And then going, in Java, I would never let you have Matt's API gateway. We'd be going into, well, hold on, what does this do? Should this functionality be broken down? Why do you need this class? And just think about all of the standard coding practices that we've been living for years. And as I mentioned earlier, but I'm doubly reinforcing it, document and test everything. Whether it's through snapshot tests, which will test nothing changes in the template, or those fine-grained assertions I showed you earlier, tests are a game changer, and embrace them, because the next thing is you want to make sure if you consumers of a construct, they are a product, so you can make changes that will change consumers' end deployed infrastructure. So you always got to make sure with your unit tests that you haven't accidentally made a change that'll delete and redeploy infrastructure to the cloud for people. Maybe you've renamed something by accident. So just always think about your consumers of your constructs, because they may have, it may be a big deal for them if something gets deleted and redeployed. Think about a thing called CDK aspects. This allows you to do aspect-oriented programming on your infrastructure. So an example of how we use aspects is that in Liberty, everything deployed to the cloud has to have a tag associating it with a real like business project. What area of the business is this going to help, as well as which team deployed it and all those kind of things. We could have created custom constructs for everything to apply those tags, but you can write an aspect that just says, as this is being deployed, apply these tags to everything. And that way developers don't need to worry about it. We don't need to maintain custom constructs, and it just happens, transparently. And then the last thing is consider open source first for these things, because the odds are, even if you have very specific requirements in your business for your infrastructure, it's probably 95% of it is the same as what everybody else needs. So if you publish a construct for your 95% needs, then you've helped everybody else. Plus, you can then internally extend it for the 5%. And I think this is how we grow as a community. If we build constructs that relate to the well-architected framework, that are documented, that understand that they have unit tests and don't break things for customers, and then we share them for others to use. This is how we lower the barrier to entry for cloud. So the further resources section, as I'm wrapping things up here, if you've been really intrigued about CDK and you want to learn more about it, well, CDK Day, which is a global virtual conference, it's coming up on the 26th of May. The call for papers just closed, so we've already picked our talks, and if you go to the Twitter handle at CDK Day, you'll see some of them have been announced as people have been excited. But this is one day where we let people talk about all of their exciting things they've been building with CDK, as well as share what they've learned. And by that, I mean AWS CDK, CDK for Terraform, CDKTF, which is the Kubernetes one, ProGen, as well as if anybody's built a new CDK that they want to share, we bring it in. And the map in the bottom right shows you where everybody joined from last year. So it's a pretty global event. It's completely free. It's all about fun. So if you want to join, as I said, it's the 26th of May, and I think we haven't fully locked down the schedule, but it's usually US East Coast time, 10 a.m. to sort of 3 p.m., that kind of thing, if that works for you. Live broadcast, but also available afterwards. Or if you want to book to learn about the CDK, well, there's the CDK book written by 4 AWS heroes. There's Matthew Bonig, Thorsten Hoger, Sadia Bat, and myself. And you can see what's included in it right here. And what's the CDK? What's a construct? How do you integrate it into your IDE? What's the best project layout? Custom resources and providers, configuration management, assets, testing, enterprise construct libraries, deployment strategies, and importing CloudFormation templates. So we've tried to package as much as we could into a book between the 4 of us, and the whole book is CDK v2 out there at thecdkbook.com. And then lastly, if you want to learn anything more about Liberty Mutual and serverless, really just Google Liberty Serverless or Liberty Mutual Serverless. It's all out there. Visit CDK Patterns or attend CDK Day and follow some of these amazing people. But that is it for my presentation.
Well, thank you, Matt. Thanks for your time, and this was a great talk. Hope to see you around soon.
Yeah, thank you for inviting me.
Thank you. Bye. Have a good day.